YouTube. It's Saturday, July 21st. I'm going to make a video about a few of the things going on. We'll start off with this one right here. Someone's found Nibiru again. Say Nibiru is near, and they give you this old picture from Microsoft Worldwide Telescope. It's been in there for a while. People look at it and scratch their heads. Well, let's look at it and see what we can figure out here. It kind of looks like almost a supernova a minute to me, but we'll take a look and see what they have. We'll go over and put the position in here. You go to the Finder chart. Put the position in here. It'll give all these three indicated. And if you click on the submit button right there, it will take you over to this window. And they'll have 5 images that they found from the DSS and also from the 2 micron. And you'll look, there's an image right there of it. And you go down, you'll see that 1999, the 2 micron, the 3 different bands, nothing was found there. Look over here, 1982, the 2B band, nothing was there. The 2R band in 1989 is the one showing this object, whatever it is. 1999, the 2IR band, nothing was there. 1954, 2 bands, 1B, 1R, nothing there. So let's take and look at it a little bit better. We'll take a look at the colorized images here. Just take and knock on that. And we get a green blob. Okay, this is the normal setting for the color bands there. And we get a green blob. Well, let's knock out that green, see what happens. We'll take and put that 0, we'll put that 0, and submit it, and we get nothing there. Okay, knock out the green band, and we don't get anything there. So what's going on with that? Let's take and reset it, and let's try knocking out this one over here. Let's see what we get. We'll get this one. For some reason you have to put a 1 in there. And submit it, and it's still there. In fact, it kind of looks orangish and reddish like it does on Microsoft Worldwide Telescope. Reset it again. Got the green blob. Let's take and knock this out over here and see what we get. And over there we get, it's still there. It's in this one band right here for some reason. 3 different color bands. The green band is there. So I have a feeling that there might be something wrong with the image. And let's go over here and look at it. And we got the blue band right there. You have to change it to GIF, or else it'll download the image instead of showing it. And there's nothing there. And we'll take it back up and look at the IR band. And there's nothing there. Okay, so oh, I got this thingy down there. Let's look at this one. This is the red, and look there, and it's there. Okay, so we got it showing up on one of the images, but not the other ones. That's basically the same thing we got over here with the color stretch. Knock out that one band, it disappears. This is the normal color here. This looks just like it does on Starry Night Pro with the colors. And for some reason it's showing up as a green band there. And again, if you take and you follow through with the finder here, you track down these people here. If you follow the right path, you'll end up here. And if you look at that picture there, it's basically the same picture. Looking at the properties, yeah, it's from 1989 right there. And that's what you get. It's not red and orange, and if you go over here and click the optical, look at that. It gives you the red and orange thingy that you got on Microsoft Worldwide Telescope. That's the exact same image right there. That's where it came from. Why they got that on there and not the other thing, or the green one, I don't know, but it looks like to me that there's something in this one band right here on that one year. And if you take and you look at the other years and the other bands, there's nothing there. So I'm going to have to say that there's something wrong with the image. And I really don't think that's Nibiru. And you can say they're hiding it on the other images if you want, but it's right there on the right image. It's just something in that one image. There's nothing on the other ones. I don't think they're trying to hide it, or they wouldn't show you that one. But whatever you want to say about it. Let's go on to the other part, though. The other part would be this article here. They were talking about this. John Moore and Bill Deagle were talking about this, saying that they had found it. It was being sighted. and it's being sighted right and left down in the southern hemisphere. Well, it says right here that they haven't found anything. In fact, they had ran a computer program looking at 92 different Kuiper Belt objects, put a model out there saying, what happens if we stick this planet in? They found out, well, if you stick the planet in there, 6 of the bodies that have the really elongated orbits work out, but the other 80 or something are not even affected by it. So 6 of the highly elongated orbits, such as Sedna and whatnot, would be explained by a planet out here at 1,500 times farther away from Earth, about Neptune size. Okay, well, you're not going to see something at 1,500 times as far away as the Sun. That's 1,500 AU. That's 50 times farther away from Neptune. Size of Neptune, you can't even see Neptune at 30 AU, much less 1,500. There's absolutely nothing in here about being seen. In fact, it says right here, if you go looking for it, it's going to be really hard to see, and it can be anywhere. They have no idea where this could be, except for a distance. The reason they gave it that distance is because anything closer would be perturbing the system as a whole that we can see. And so they make it this far out to where you wouldn't be able to pick up the perturbations. They also talk about a Mars-sized object with a highly elongated orbit that would occasionally bring it into about 54 AU. Well, anytime it stuck its nose inside of 100, you would probably be able to see it. And there's nothing being seen. Eris is out there about 100. You can see that, but you can't see anything else. And this would be bigger than Eris. So there's nothing on here that says it's been found, that they're looking at it, and they don't even know where to look. So I don't know, they must be looking at a different article or not being quite truthful, because there's nothing in this article that says they have found anything. And if we go on from there, Bill Deagle likes to talk about a red dwarf inbound, a class 3 red dwarf. That would be this one right here. That'd be 36% as masses of the sun, and almost 40% as large. And it would be putting out quite a lot of light. You would be able to see it. A red dwarf is not invisible. A red dwarf is actually ignited and putting out light. I think he's confusing it with a brown dwarf, because he goes on to describe a brown dwarf that is not ignited. A red dwarf is ignited. There are many red dwarfs. In fact, red dwarfs are the most common stars in the galaxy, and the closest star we have is a red dwarf, Proxima Centauri. It's an M5, which is less than an M3, and at 4.2 light years away, it's got an apparent magnitude of 11. If you move that thing in close to the solar system, you would see it like another sun. So you must be talking about brown dwarfs. That's all I can say. If one of those came close, you'd know about it too. But the Harrington orbit that we got, it's from here. It's the 1988 paper. He gave the orbital elements here, and that's what I'm using in the program. And there's an interesting thing on here. If you look down at the bottom, remember Jones? Well, there it is right there. R.S. Jones from 1988 talking about Planet X. There's a few other papers between here and now where Jones is talking about Planet X. Seems to be a favorite topic of his. He was even involved in the first Planet X back in 1988. And now he's come out with a new one over here in 2012, and he still hasn't found it. Been looking for it since the 80s and still hasn't found that 10th planet yet, but he just put out a new theory to take up for the one that's no longer valid. This one over here was disproved. For one thing, the perturbations of Neptune and Uranus were solved by the flyby of Neptune, and even if it wasn't, at this current distance of about 109 AU, you would be able to see this object out there. Like I was talking about, you see Mars that pass inside of 100, around 100. Well, this thing would be much bigger than Mars. You would be able to see this also. And we actually know where to look for this thing. Or you don't know where to look for the other one. This is the orbit. You can twist it around a little bit there and get it whichever way you want to. Now basically, here's Pluto right here. Here's the Sitchin orbit. That's an 11,500 year orbit. And here's the Planet X orbit. Goes outside of Pluto, counterclockwise orbit. Planet X right there. How do we know that? Well, that's where the orbital elements put it, and we also have a video. This is his video, and he shows it right on here, and it agrees exactly with what's on the program. You can see him explain it. There's the inner planets. That's Pluto. And look at that one. That's Planet X. And there's Planet X right there. Look at that again. That's Pluto. And there's Planet X. Outside of Pluto, counterclockwise, with Planet X on the outbound leg. That's exactly what his orbital elements from 1998 show. The other one is Nibiru. Where did we get the Nibiru from? Well, there's a few things out about it, but it's also in this movie. And I like to hear Harrington talk about it because Harrington was an astronomer and he does have a pretty good idea about how to make diagrams up. But this one's a little bit strange. Now you can see right there that it almost looks like it's on the same plane as the ecliptic. But the others, if you look over here at this one, shows it going almost straight up and down. And a lot of other people talk about it going straight up and down. But on this one, you can see it. He has the Earth right here, Sun's there, this is the Earth, and here's the closest approach right here to the Sun. Well, that's the Earth. He doesn't have anything inside of the Earth. That's the Earth. That would be Mars's orbit. That would be Nibiru. That would be Jupiter. That would be Saturn. That would be Uranus, Neptune, and Pluto. So he has this thing coming and staying outside of Mars's orbit. Here's Mars's orbit right here. So he has it staying outside of Mars's orbit, coming inside of Neptune's or Jupiter's orbit, about halfway to the Mars orbit, and then going back out. Actually, it goes around this way. It's clockwise on this one. So he has it staying basically outside of the Mars's orbit. Okay, and I guess you could twist it around and make it look something like this, but most people trying to say that it goes straight up and down, where this doesn't quite show that, so that's weird. But this is a 3,600-year orbit, clockwise, so this would be inbound right here, and that's about halfway from the two extremes. And if you made that halfway from the two extremes, like it shows right here on Dr. Harrington's diagram of it, it would look a lot different from what you're being told. I made this a little bit narrow, trying to get it to conform to the August 17th and September 26th close passages, and I couldn't get it to work. It just it would take much longer than that to go in and out. We can take and pull it back here, and that's about the best you're going to get it, right around in there. Now that is a 3,600-year orbit, basically the same thing that Harrington was pointing to. And Harrington has it about halfway down. I got it up here because I was working on it. But we can take and move it. Let's take and move it down about halfway. Take a look at what it looks like. I was playing around with it here. And if you pull this one down, you can bring it down to where it would match Harrington's diagram. That would be around in there. Pretty close. About halfway in between the two extremes. That was 1990, so let's go back to 1990. Make sure it's about right. And yeah, that still looks about right, doesn't it? We're looking at about halfway, depending on which way you orient this thing. That would be about there, I guess. So it's halfway in 1990 on the inbound leg. And like I say, it's kind of narrow because I was trying to get the other part to work out. It wouldn't work. So let's go to now. And that's where it would be now. And it hasn't changed much, has it? It's a long way out. When things are a long way out, they don't change much. So we can take and measure that and see where Harrington's position would have been. And from down there to the sun would be 210 AU. 210 AU. Well, that's almost twice of what Planet X would be to Nibiru. And that's from Harrington's diagram. You can see it right there. halfway out. Now, people want to talk about Harrington's diagrams. Well, there it is right there. You can't argue with it. The only thing you can argue with is why this one over here shows it straight up and down and shows this thing up here when everything else says it should be the other way around, that the close approach is out here. So I don't know where that thing there came from, but this came from Harrington. He's pointing at it right there. Clockwise orbit, halfway. That's what we got right there. Clockwise orbit, about halfway down. 210 AU away. That's an awful long way out. So anyway, I tried to get the other parts to work where it went up above the ecliptic, around the sun, and then back down and close pass again on the way out. And it takes about over 6 months. There's no way you can do it from August 17th to September 26th. And if you take and you work that around, you can see that it's actually closer in than Harrington's diagram. In other words, Harrington's diagram has it staying outside of Mars's orbit, and I couldn't even get it close if I did that. If I stretched it out to where it stayed outside of Mars's orbit, it wouldn't even come close. So that's what I came up with trying to work with it. And like I say, on his, it goes outside of Mars, in between Mars and Jupiter. This is Jupiter right here. We can take and run it back over here, and don't save this. It'll bring it back up to where it should be. There it is. So basically that's where the ecliptic would be on the 17th of August. Let's go up to the 17th of August. There it is right there. Yeah, the Eagle star is right about on the ecliptic, pretty close. So let's see how long it would take. Here's that's about 2 AU away, a little bit less. I tried to get it to be 2 AU away inbound, and then have it circle over the top and go back around the other way and see what that would do. And this is what I came up with. That was August 17th. This is September 26th. Thing hasn't even got halfway to the top yet. There's no way this thing can come in on that orbit, pass us close on the 17th, and then pass us close on the 26th. It takes much longer than that. And that's it's just now getting to the top. And on this leg right here, it would get even a lot closer than the 2 AU. But then on the way back out, it would take until about now to get down to the ecliptic again. Run it back a little bit here. So that would be right around in there when it crossed back across the ecliptic on the way down. That would be February 1st, 2013. So August 17th, February 1st is how long it would take to make that loop, and that loop is even tighter than the loop that Harrington shows. So I couldn't get it to work. I tried, and not much else works either. But if you look at the video, look at Harrington's diagram right there. We did that. It's 200 AU away at present. It will take an awful long time to come on in. Neptune's at 30 AU. So you're talking almost 7 times farther away than Neptune, if it even exists, which it probably doesn't. So the other part I wanted to show was over here on the, this is current view right now, and this is the ecliptic right here in purple. And the ecliptic, anything below there, look at that, I can see all the way down the Canopus there, if it was night. And Canopus has a -52 declination. So I can see below the ecliptic just fine. That one's -16 degrees. So anything coming in, there's the Eagle star right there. And Eagle star has a, it's only 26 below right there. But anything that's below the ecliptic is not hidden from us up here. In fact, you can take and run it ahead and see the ecliptic does change with the time. As the Earth rotates, the view of the ecliptic changes. That's called field rotation. You see the Eagle star coming up here, and here's Planet X down there. So I don't know where people think that people in the northern hemisphere can't see below the ecliptic, because you can see just fine. In fact, at 30 degrees north, you can see all the way anything that's down around 60 degrees south. You can look at right here and see that this is the Southern Cross down there, and that one's at minus 57. This one right here is at minus 59. And here's the Harrington theoretical Planet X and the Deagle star theoretical. And it comes up just fine. And they are both below the ecliptic. Planet X is minus 36 right now at 109 AU away. And if you put Deagle star back down to where Harrington said it was, it'd be 200 away. Over 200. So that's it. I just wanted to let you know you can see below the ecliptic no problems. And if you go by Harrington's diagram, it's not exactly the same as what you're being told today. Planet X is the same. But Nibiru, according to everything that I've seen, is an awful long way out. And if you look at the one over here from 2002, Sitchin confirms that it won't be back until 3440. He says it right here. He says it's the Anu visited Earth 3760. Minus that from 3600 would be 160. Minus 160 from 3600, and you got 3440. That's the latest on Sitchin, 2002. Doesn't agree with the one back here exactly, but it agrees a lot more than what's being told. So I'll talk to you next time. For the color bands there, and we get a green blob. Well, let's knock out that green, see what happens. I'll take and put that 0, and put that 0, and submit it, and we get nothing there. Okay, knock out the green band, and we don't get anything there. So what's going on with that? Let's take and reset it. YouTube is Saturday, July 21st. I'm going to make a video about a few of the things going on. Start off with this one right here. Someone's found Nibiru again. Say Nibiru is near, and they give you this old picture from Microsoft Worldwide Telescope. It's been in there for a while. People look at it and scratch their heads. Well, let's look at it and see what we can figure out here. It kind of looks like almost a supernova for a minute to me, but we'll take a look and see what they have. We'll go over and put the position in here. You go to the finder chart, and nothing was there. The 2R band in 1989 is the one showing this object, whatever it is. 1999, the 2IR band, nothing was there. 1954, 2 bands, 1B, 1R, nothing there. So let's take and look at it a little bit better. We'll take a look at the colorized images here. Just take and knock on that, and we get a green blob. Okay, this is the normal setting part. Put the position in here to give all these 3 indicated, and if you click on the submit button right there, it will take you over to this window, and they'll have 5 images that they found from the DSS and also from the 2 micron, and you'll look, there's an image right there of it. And you go down, you'll see that 1999, the 2 micron, the 3 different bands, nothing was found there. Look over here, 1982, the 2B band. And let's try knocking out this one over here. Let's see what we get. We'll get this one. For some reason, you have to put a 1 in there. And submit it, and it's still there. In fact, it kind of looks orangish and reddish, like it does on Microsoft Worldwide Telescope. Reset it again. Got the green blob. Let's take and knock this out over here and see.